you can see, the first one, it's going to be manual. I'm going to go over it, and videos. So when we are going to go over manual pretty fast, we are going to have the first mistake right here. I don't know why we are not fixing it. Guys, in manual, I'm going to talk with Dr. Tiana. I didn't know we still have it there. We are not going to analyze the human sample, tooth sample. No, we don't have such a thing. Even in the movie, you are going to see it. We are going to give you the alligator tooth sample. And then you had a student, they were supposed to prepare the solution out of it. So grinding, dissolving in a very high concentrated nitric acid, and then dilute it. Please, please read it carefully, the dilution part, because this one, you need it in your calculation. Okay, so introduction, of course, it's talking about the concept behind atomic absorption and atomic emission. What was this about? How we are gonna do this to process right there. So, of course, it's based on the Beer-Lambert, all those facts and concept. Then it's going to reach the experimental part. Again, as I told you, and you can see in this table, we are going to have a couple of different concentration in ppm. And then the first part that we took care, it was atomic absorption. You are going to see the machine in the movie. It's a pretty nice one. Usually it's not giving us hard time in the lab, although it's not a very brand new one. So the setup was easy, and we are going to read all those ppm concentration for 3 elements, 3 metals. You see right here, Fe, Pb, and Ca, the most metals we are going to find in the tooth sample. So the range, it's from 0.01 to 100 ppm. Checking the absorption for all these, and finally, at the end, the tooth sample. The only downside of this machine was fluctuation of the numbers, especially in lower concentration. But right now, because we are providing you the mock data, you don't have to be worried about this part. You have just the numbers right there for you. So this is the general look of the sample. In the middle, we had a flame right there. Left side was cathode lamp. So we are going to have one particular lamp for each element that we had to choose when we were running the set of the sample. For example, we were starting with Fe or Pb or calcium right there. So this machine, it's going to read the numbers for each element at a time. We couldn't run all 3 at the same time. So it was pretty time consuming. But because we were reading the number at the just 3 seconds, so it was pretty fast, not that much time consuming. So as you can see in the picture, we were leaving the hose that it was pumping the sample to the flame. And on the right side, we were reading directly the absorption. So pretty straightforward. This is the cathode lamp that we used to have. You can see it right there. And actually, we were not opening this part. This is, showing you. You were rotating those left side to have the proper lamp. And of course, nanometer for setup. You are going to see all this in the movie, in the film. You will see what we are going to set up the machine. Pretty, again, easy and straightforward, all this part. My suggestion, guys, if you haven't done so, read the manual one time, watch the movie, and again read the manual one more time. This way, you are going to make sure that you understand everything. Do these 3 steps for AA, then switch to the ICP. So when we are collecting the AA data, then it's time to run the ICP. Okay, ICP, this one was pretty time consuming because it needs lots of preparation time. So we had to open the gas to gas well for this one. So leave it, for example, for the nitrogen and argon gas, leave it for 20 minutes. Then it was time to start the chiller. Then we had to wait until the chiller temperature is reaching 20 degrees Celsius. Then we started running the pump. It's flushing the sample inside the machine. So again, we were giving it sometimes 10, 20 minutes right there. Then after all this and checking if you, for example, all parameters, number, camera temperature, optic temperature, everything, it was set, then it was time to ignite the plasma. Okay, then we could ignite the plasma. Everything it's going to be done on the computer right there. Pretty easy and straightforward. And then when after 10 minutes, we have the plasma stable, then we had to do the calibration. Calibration is happening right here with the 0, that is blank water, pure water, and 100 ppm, that's the highest concentration. So for each sample. The good part about the ICP, it's running and measuring all 3 elements at the same time. So when we were done with the preparing the machine, the next part, it was pretty fast. So we just leave the hose inside the sample. It's flushing and pumping the sample inside the plasma, measuring it 3 times by itself. This part we had to do manually in AA. And then it's gonna get average, standard deviation, everything, giving us the number to us. So pretty new and good device right there. Although it was so sensitive, sometimes it didn't like us and it wasn't running properly. But if it was giving us the best numbers and precise numbers right there. When we were done reading our all samples, again, a story was starting, shutting down the device. It was again 10 minutes after plasma, then chiller, exactly going backward. And the most important part, we never turn off the whole machine. So the chiller, just that one. So this was about the ICP. And then we were collecting all data. So let's go back right here. Let's take a look at the data that we have.
Quick question. Realistically, how long would that normally take? Like a couple days or?
Exactly, this one for sure. Usually we have 2 weeks, right, like now, to run each experiment. For this one, the first day was all sample preparation. Imagine 10 sample dilution for Fe, 10 for calcium, and 10 for Pb. So that one was planned for the first day. Second day, we were doing AA. It was pretty nice. All the students, they could finish AA in 1 day. Then third day, it was starting the ICP. Usually, I was asking my student to be as early as possible. So for example, the lab was starting at 8. I was there at 7:30. I was asking a student to be there too, because we could save time to start the gas that needs at least 20 minutes earlier. So we could save time and make sure we can do as much as we can in the same day, because we had to go out of the lab at 10:45 because next group, they were coming at 11. So again, if we were, pretty fast and not wasting that much time, usually we could finish it in 3 days. If not, some of the sample, they were remaining for the 4th day. So yeah, it's a pretty long lab.
That's wild.
Oh, hold on. This wasn't the worst one. We had,
Oh boy.
yes, usually fluorescence. Oh my God. That one was the longest one. And the shortest one, it was GC. Okay, so look at the data. The first part, it's from atomic absorption. You can see we are gonna read absorption for each concentration that we have. So, and actually you are gonna have the numbers for three readings for each concentration, as you can see right here. Guys, please pay attention. So these are the real readings. Okay, make sure to for averaging, you need to get average from these 3 readings. If you see some numbers, they are so off, you don't have to include it in your averaging. Please remember that one. So sometimes we have outliers, and I hope you all had 251 lab. We have the Q test in 251, so you all know that if we have an outlier, how we can check if we need to keep it or we just need to neglect it and not include it in our calculation. So make sure to use all analytical methods and calculation. So you choose the best data you have right there. And at the end, please pay attention that we have the numbers for unknown sample. So as usual, you are gonna make a calibration curve for these 3 ions and include your unknown there as well, and find the concentration in ppm for tooth sample for these 3 ions right there. The next set of data, as you can see right here, this is the emission one, the result from ICP. So again, make a calibration curve right here and find out what is the unknown concentration. One important thing that right now I need to attract your attention, guys. Please remember, when you read the manual, we are gonna have a dilution, 10 times dilution in tooth sample. So the numbers for atomic absorption and emission that you have right here, it's belonging to the diluted sample. In your report, you need to report the numbers ppm, and so you need to report ppm for calcium, Fe, and Pb. In addition, you need to report the percentage, because again, you see in the manual, for example, it says the highest percentage is for calcium, blah, blah, all those. So we need to see what is the percentage that you calculated right there too. So both ppm and percentage from AA and ICP. But remember, please, those numbers in your report should be for original sample of tooth, not the diluted one. Please pay attention to this part in your calculation. Usually a student, they forget about this one at the end. So in your conclusion, in the result and discussion at the end, conclusion, and in your abstract, I need to see the ppm and the percentage for these 3 ions for original sample, not the diluted one. Of course, in result and discussion, I would like to see all of them. So the diluted one and sample of calculation to show me the original one. Please make sure to include sample of calculation in your result and discussion. I just don't want to see some random numbers right there. Are we good, guys?
All good.
Yeah.
Is this clear?
Yeah.
Do you have any question for me? So again, please read the manual. My suggestion, read AA, watch the video for AA, go back one more time, read the manual for AA. This way you are nail it down. And then do the same for ICP. If you have any more question, I'm gonna be here Wednesday at 10 a.m. to answer any question that you may have. And right now, please ask me any question that you have. I'm gonna go back to the Zoom.
Just as far as that mock data goes, I'm just putting it into an Excel sheet right now.
Absolutely. You are gonna transfer those data to Excel sheet, and you are gonna draw the graph. Make sure you have a clear, nice trend line for each ion, showing the equation, because you need that equation to calculate the concentration of your unknown sample.
For the final report, do you want us to keep each curve on a separate graph, or can we consolidate all the data onto a single graph?
You can do it in one single graph as long as it's not pretty busy. So I would like to see each equation clearly in the graph for, each ion. It's up to you.
Okay,
Once-
so either or.
One single graph, it's going to be good enough, but please make sure it's neat and clear.
Appreciate it. Thank you.
Any more question, guys? Are we good?
I'm good.
Same.
Wonderful. Yes, I'm sure when you read it. So please, my suggestion. I'm sure you are busy. You have lots of other stuff to do, but please make sure to do this one as soon as possible. Then you have time to ask me any question that you may have. In the rest of this module time. You saw that I graded your first module.
Yeah, the
So we
statistics.
had some, I thought because some of you didn't ask me any question. I thought everything is pretty okay. Then I saw some wrong number in the calculation. Guys, I'm not gonna be happy when we are missing points right there. So please make sure to clear everything before submission. Are we good?
Yeah,
Mhm.
I just for clarification, Margin. So on the mock data, the top is the absorption and the bottom is emission.
Yes.
Okay. Awesome.
Even it says in the data that's emission, and that one, the top one,
You're right. I did not pay attention to that. Thank you so much.
Yes, we make.
Sorry, it's too early. I'm glad we're moving it to 10 o'clock.
I know. Yes, because guys, this one, as I told you, the first day of module, it's the longest one usually, and we are gonna have it less than half an hour talking. So because of that, so okay, let's shift it. So we are gonna be more awake and absorb more of this class.
It's still only the same thing. Only the first day of the module when we start is mandatory, correct?
Exactly. So I
Okay,
double
cool.
checked almost everybody but Nabil. So I'm not sure if he still wants to keep the course or he's dropping. I don't know. So I may contact him. Okie dokie. More question, guys.
You said you will be here on Wednesday in case we have any questions about the procedure, right?
Absolutely. I'm gonna be here 10 a.m. Monday, Wednesday with the same link of Zoom in case you have a question, guys. Don't
All right.
worry about it. I'm gonna be here, but the first day of each module is mandatory. You don't have to come on Wednesday and next week, but I'm gonna be here at 10 a.m. in case anybody has a question.
Thank you so much. Appreciate that.
You're welcome. More question, everybody?
I think my last one would be, when can we estimate a return feedback for module 2, just so we can see, you know, because this is actual our first report that we
You
turned
just
in.
submitted last night. Okay. I'm trying to make it,
No, yeah, no rush, no rush. I was just curious.
No, I'm just kidding. So I'm trying to grade those and write down feedback if it's necessary. Sometimes if you don't see feedback there, means it's in pretty good shape.
Okay.
So I try to grade it before your next submission.
Awesome. Thank you so much, Margin.
No, just for this one, okay? No promise for the rest.
No problem, no problem.
So for this one, just if you need a feedback telling you, okay, which part needs more improvement, so you are gonna apply that one in your future report as well.
This is more of a report question, but when I was writing the procedure, like since we didn't really do the procedure in person ourselves, I was kind of confused on like how much to include in terms of like operating the machine, things like that.
You don't need to be worried about that one too much. When you are writing down the introduction, focus more on the concept, please. Explain more the concept. Then for experimental part, you don't need to talk about procedure step by step. For example, we turned on the machine, we rotate for example, for AA, we rotate the lamp, cathode lamp, we set the lambda. You don't need, as you said, you didn't touch the machine. Even when we were face to face running it, the procedure is completely in the manual. I don't need you copy paste it there exactly step by step. Just in cases that each student, they were experiencing something in addition to manual, I was asking a student to include that one. It doesn't apply to you guys, so I'm not going to be that picky about the experimental part. So as much as you can go, a little bit general of that. So I pay more attention. So of course I need a good abstract at the beginning, then a nice introduction, talking about the concept, how much you are going to show me, how is the concept, then experimental part as much as you can, and of course result of discussion, it's the most important part, and conclusion. But usually in general, regardless of situation right now, when you are writing down the lab report for one experiment, you should consider, if you're handing this report to somebody that doesn't know anything about its experiment, they should get a good idea what you did in that lab and how you did it. Okay, so
Makes much more
that
sense.
one.
Thank you.
Exactly. For example, I know you are writing it for me as an instructor, but imagine every time you are writing down a report, you are going to give this one to somebody doesn't have any idea that how you did it in the lab. Basically like a paper that we are going to do, in general. So lab report and paper. So you are giving an idea to somebody else that how you.
Appreciate that. I'll note that for next time. Thank you.
Any more questions, guys? Okay. If you don't have a question, have a good day. I may see some of you on Wednesday.
Awesome. Thanks, Marjan. It's time to start reporting.
Thank you.
Thank you. You're welcome. You're welcome, guys. Have a nice day.
You as well.
Thanks.